the standard equation of a plane that has normal ABC, all right, and has the point x naught, y naught, z naught, right? Now, is the choice of normal unique? Certainly not, right? You could take this equation, multiply it by any non-zero number, you wouldn't change the solution set, right? That's just basic algebra. Well, that corresponds geometrically to the fact that you can take the normal and you can rescale it and make it as long as you want going up, or you can flip it over upside down and make it as long as you want going down. Those are all still normals to the plane, as those vectors are perpendicular to the locus of all possible tangent vectors emanating from the base point. All right, there you go, that's the equation of plane. Now, of course, you can do other stuff, right? You can do things like make the equation pointless. Check this out. So here's the pointless equation of a plane. Okay, it doesn't really have a name, but sometimes people call it the general, I don't know, whatever you want to call it. I can tell you things from that equation that are nice, like here's something. Does your plane go through the origin? Categorize that in terms of ABCD. Go. Again, does the plane go through the origin? Yes or no for the plane ax plus by plus cz equal to d. If you think about that, the question is just, is d equals to 0 or not? If d is equal to 0, it goes through the origin. If d is not, no. All right, we assume that this must be said. This must be non-zero. What happens if ABC is equal to 0? What's this equation then?
The point.
It's worse. So this is the difference. That was a parametrization. When the parametrization is trivial, it tends to give you like a point. When the equation is trivial, it's dual to that. It gives you everything. So if this is 0, you just have 0 equals 0. When's that true? For which x, y, z is that true?
Everything.
Everything. So it's just like, it's all of space. So, which is, you know, okay, well, there you go. But I guess 0 equals 0. Which points in space does that specify? It's a question of context, you know. All right, let's look at some examples here that kind of bring everything together. This is a very popular question on test 1, so let me work it for you. If I haven't put this in the homework, well then, by golly, I should not be allowed to teach calculus 3 again. Ooh, I don't want to say that. This is my favorite calculus. I sure hope I put it in the homework. Man. Oh, the quiz tomorrow is not on this stuff. The quiz tomorrow will be on vector addition, unit vectors, vector length, orthogonality, angles between vectors, dot products, cross products, all that material, not lines and planes, obviously, because it hasn't had a chance to percolate. All right? And the quiz won't take too long. It'll be pretty short. All right? So example, where am I? I can't. Oh, that makes this example 3 then. Because that's like 2.71 something or other, right? So actually, I will take this opportunity to share something with you. If I've got P, if I've got Q, if I've got R, and these are coplanar points, all right? And if I wanted to parametrize the parallelogram in space, like this, suppose I wanted to parametrize this thing. Now I'm getting ahead of myself, but it feels natural to say this to you guys today. This is not a test 1 question necessarily. My brain has skipped to something else. So just stick with me here for a second. If you wanted to parametrize this line segment, if you wanted to parametrize this grid, all right, you could use the following. You could use R of, let's say, I don't know, S comma T is equal to P. We'll use P as kind of the base point, and then plus T times R minus P plus S times q minus p. I believe that would do it if we have 0 less than or equal to s comma t less than or equal to 1. That's the kind of thing that you would use to parameterize. And if you wanted to parameterize the plane containing those 3 points, you just don't bound s and t. You just let them go on and on. That would give you a parameterization of the plane containing these 3 points. And if you want, you can check me on it, right? Like, what's r of 0, 0? What's r of 0, 1? What's r of 1, 0? What's r of 1, 1? R of 0, 0 is, look at this formula. What happens when you put s and t both 0? You just get the p, right? What happens when you put s equals to 0, t equals to 1? You get r. And let's see here. So r is equal to, this q is going to be 1, 0, right? And then this point up here is actually what?
P plus q plus r.
Yep, p plus q plus r. Yeah. I think that's right. No, I don't think that's right. It's what? Well, if we put 1 and 1 here, we get p plus r minus p plus q minus p, which means we actually get r plus q minus p. Anyway, let me come back to this more later. Oh, fine, let me just finish it. If you had vectors, if this was vector A and this was vector B, I regret this, but I'm this far in, so here it is. Then the parameterization of this would be P plus T times A plus, let's say, S times B. If that makes sense. Like, you're basically just starting at the point P and you're adding scalar multiples of A to go one way, and you're adding scalar multiples of B to go the other way. And as those range over all S and T, you fill out the plane. This would be a parameterized plane. I think I have a whole day devoted to this later, so I'm getting the cart before the horse here, but we'd like to start with the equation of the plane. So my question then is, if I give you 3 specific points, let's be more specific. All right. So let's say 1, 2, 3, because I love that point, right? And 1, 0, 0, and 8, 7, 0, right? These 3 points. Then my question is, what's the equation of the plane which contains these 3 points? So here's my question again. The question is, given 3 points, how do you find the equation of a plane containing those 3 points? Here's the way we do it. You need to find the normal to the plane. That's really it. So how do you find the normal of a plane that contains 3 points? You need to think about the vectors which connect the points. So this is maybe vector A, right? This is vector B. And of course, A cross B is what? Normal to the plane you want. So what is A, though? Specifically, A is equal to? Well, we got 8 minus 1 is 7. 7 minus 0, 7. And then 0. What's B? 1 minus 1 is 0. 2 minus 1 is 2. 3 minus 0 is 3. Calculate their cross product. A cross B. All right. So we do 2, 3, which is 21, minus 0. And then the y component is 3, 1, so we do 21, so 21. And then the z component is 14. That feels wrong. Like I'm definitely missing a sign here. Let me think through that a second. 3, 1. Well, that was a minus 21. Let's see, z. Wait a minute. My bad. Why z? No, that's fine. 21, c1. Minus 21, I think. And then xy. All right, so listen, as I said, if you're a little bit uncertain that you did the cross product correctly, which would be me right now, what should I do? I should check the dot product of the two vectors. It's 0. If I get 0 for both, then we know that despite my, freewheeling kind of nonchalant way of calculating just now, I'm right. So when you take the dot product of A with this, you get 7 times 21 minus 7 times 21, 0. Woohoo! When I take the dot product of this with that, I get minus 42 plus 42. It's everywhere. 0. So yeah, that's the normal. Woohoo! What's the equation for the plane? (21) times x minus 1 minus 21y plus 14z equals to 0. Now, what should we do with that? What did I use for my base point to write that down?
The point that the vectors came from?
Right. Which one was that? I mean, I used one. Yeah, that's right. I selected this to write the equation here. We can clean this up a little bit, right? Like let's divide by 7, right? If we divide by 7, we've got 3 times x minus 1 minus 3y plus 2z equals to 0. Or if you like, we could write this in the form 3x minus 3y plus 2z equals to 3. And there you go. I mean, listen, you can write this however you like. I mean, is there one right answer? So at this point, basically, my college algebra will assail me with, which way do you want the answer? Which I have to calmly assure them that I am not their high school algebra teacher, and I understand the equivalence of answers. You can give me any logically equivalent answer. I'll probably count it correct, unless you're inconveniencing me greatly and making me do many calculations to figure it out. And then I'll take like a half a point off just to like try to not get you to not do that again, because at the root of everything, I'm lazy. But, well, I don't know. But you guys can answer questions for me, like, is the plane that we've just found here go through the origin? It does not, right? Does the plane, but we can ask, and then, so like, then you can start mixing concepts. How about this? This line over here that we found, 1, 2t, 3 plus 7t. Does this line intersect that plane? How would you figure that out? What would you do? Does this line intersect that plane?
Set x, y, and z equal to their t components.
Ah, so correct. Sam has the right idea. We take these purple equations right here, yeah, and you just chuck them in there. And if you can find a solution, then that will tell you which t to choose, right? It'll tell you what t to choose to plug back into this formula to give you the point, which is on the plane, where that line intersects the plane. All right? So anyway, we'll do more stuff like that in future. But anyway, sorry if I'm a little bit behind. I get too excited about the triple product thing.